Assalamu alaikum and welcome to the last part of the integration series. Okay, so let's start with model number 14. And after this, we will only be left with model number 15, which is the last model. Sorry, this is model number 14 and model 15, which will which we will study after this model will be the last model. Before I proceed further, I would like to say that if you haven't subscribed to our channel, make sure to do so now. And if you want personal tuitions from me, then contact me in the number provided below. All right. So model number 14, area under the curve. So this is a model which you have already studied in AS. So, but regardless of the fact that you have already studied, we are going to still recall it fully. So even if you don't remember it, you can easily recall. All right. In order to find the area under the curve, the area under the curve, we will integrate the curve within the the curve within the specified shaded limits as follows. And just a reminder, area under the curves, area under the curve means area between the curve and the x axis. All right. So now we're going to look at a couple of prospective possible cases that are usually tested and how to find the area. So let's say we have with us this curve fx and we need to find this area. This is the area that needs to be found. All right. So it could be lower limit a, upper limit b, and fx. All right. Let's say we have function fx and a straight line gx. All right. And the area required is this. All right. This is the area required. So it would be a b fx plus b c gx. All right. Because this is a different function and this is a different function. Similarly, let's look at a couple more cases. This is fx. All right. But now this time, this area is required. All right. So in order to find this area, AB fx minus uh, ABGX. This would give us the area of this shaded region. All right. Now let's say we have AB, this area that needs to be found. So it would simply be AB fx, and this is fx obviously. So this is how you find area under the curve. And there's one thing which I would like to add here. I would call it a rare case. All right. So that rare case is if the area, if the area between the y-axis and the curve, and the curve is required. All right. We will first make, we will first make x the subject, x the subject of the formula, of the formula, and then apply, and then apply the limits on the y-axis. If the area between the y-axis and the curve is required, meaning that if the question requires this area, all right, this area between the y-axis and the curve, the y-axis and the curve, then we will first make x the subject of the formula and then apply the limits on the y-axis. Limits, obviously, this would be a and this would be b. All right. We'll make x the subject of the formula and then apply those limits. All right. So this is a rare case and not usually tested. But if in case it comes in your exam, this is how you're going to do it. Now, coming back to our earlier discussion of area under the graph in normal condition. All right, let's do a couple more cases. Let's say this. This is what we have. All right, this is function fx. This is a, this is b, and this is the area required. All right. So again, this is still area under the curve because remember one thing, whenever it asks you the area under the curve, it will always be from the curve till the x-axis. This is the x-axis, right? From the curve till the x-axis. No matter if the curve is below the x-axis or above the x-axis, it does not matter. The area will always be from the curve till the x-axis. All right. So in this case, it would be AB fx. Let's look at another example. All right. Let's say we have, look how beautiful this curve is. Only the examiner has the guts to give this such give such sort of a curve in the exam. But anyways, all right. So yes, if this area is required, then again area under this curve and plus area under this curve. And let's label it. This is A and this is B. So it would be AB fx plus AB gx. All right. This is a separate curve and this is a separate curve, and we will add both these areas to get the shaded region. All right. I hope you are copying with me because this is something which I told you at the very start in lecture one, and this is something obvious. All right. So we will draw a similarly beautiful diagram, which again only the examiner has the guts to do, guts to give. So let's say we have this diagram, and this is gx, this is A, this is B, and this is the area required. All right. So this area is gx minus fx. So AB gx minus AB fx. Gx minus fx will give us this shaded region. All right. Okay, so I think we are done with this model. And I believe I should give a little clarification on this one. Let's do a proper example for this one. All right. Let's copy it. Um, copy, which is Control C. All right. Let's look at this rare case. As we wrote that if the area between the y-axis and the curve is required, we'll first make x the subject of the formula and then apply limits on the y-axis. There is a little correction here. Let me properly explain it. All right. This is why, this is one more reason why you should never start a video and leave midway, because at the end there might be some corrections. And this is not just me, but generally a general advice. Whenever you watch a video of any channel on any place, watch it entirely what the teacher or someone else has to say. All right. So as we studied, if the area between the y-axis and the curve is required, we will first make x the subject of the formula and then apply limits on the y-axis. Let's say we have this fy, and this is, let's say, p, and this is, let's say, q, and we are required to find this area. All right. What we will do is make y the subject of the formula and then applied limits as follows: p, q, fy. This is how we are going to do it. All right. A correction here, a correction here is that this is going to be the lower limit and this is going to be the upper limit. Previously, I said that this is the upper lower limit and this is the upper limit, but that was wrong. Let me correct myself. This is the lower limit and this is the upper limit. All right. I hope this is very clear. All right. Lower one is the lower limit and upper one is the upper limit. As simple as that. That's how you remember it. All right. So moving forward to our last model, model number 15. And this is volume generation. Personally speaking, from experience, I haven't seen this model tested in A2. But again, it's part of your course. AS knowledge is expected. All right. So you should be studying it. All right. When the graph is rotated, when the graph is rotated 360 degrees, 360 degrees about x or the y-axis or the y-axis, we will apply integration, to find the volume it generates, to find the volume it generates. All right. So, all right. What do we mean by 360 degrees about x-axis? This is the volume we are talking about. Let me give you a visual. This is x and this is the graph. When this graph is rotated about 360 degrees about x-axis. So this is the volume. Let me draw a neater diagram. If we rotate it 360 degrees, so this is the volume which is generated. All right. And this formula, this formula is used to find this generated volume. And this should be dotted lines, but this is just a visual for explanation. All right. So this should be the volume generated, and this is what we will find through this formula, which we are going to study. All right. So steps to calculate the volume that is generated when the curve is rotated, when the curve is rotated about x-axis, about x-axis. Step number one. All right. Make y the subject of the formula. Make y the subject of the formula. Step number two. Square the answer of step one. Square the answer of step one. Step number three. Apply limits on x-axis. Step number four. Apply the formula. and this is the formula. Limits a, b, these are the limits a, b, all right, pi y square, right? These are the steps that you need to follow. Now, let's say if the curve is rotated about y-axis, right? All right. Steps would be, it would pretty much be the same steps. Make x the subject of the formula of the formula. Step number two, square the answer of step one. Square the answer of step one. Step number three, apply limits on y-axis. Apply limits on y-axis. Step number four, apply the formula. This is the formula AB pi x square dy. Let me give you a visual. What does rotation on y-axis mean, right? Let's say this is A and this is B and this is the curve. So a rotation would mean a 360-degree along the y-axis. All right. So it would be something like this. This is just a visual for your understanding. This is the formula you should remember if the rotation is on the y-axis. All right. So with that being said, we are now done with integration. Now all you need to do is practice a lot of questions. Practice, 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 practice day and night. Practice when you wake up. Practice when you go to sleep. Practice when you talk to a friend. Practice when you're with a friend. Just practice, practice, and practice, and you will eventually get the hang of it. All right. So, and one more thing I would like to add here is that subscribe this channel and obviously uh, stay up to date. And if you need personal tuitions from me, DM and let's connect. All right. So yes, thank you. Take care. Allah.